Okay, today we're going to talk about relative formula mass and relative atomic mass. So we're starting to look at the mathematics of chemistry. So that's really exciting. The relative atomic mass, we're going to start with that. So that's the atomic weight. That's the averaged weight of all the isotopes of a particular element. So we've got to remember that an element like carbon, for example, has a number of isotopes. Um, and if we were to just say, what's the mass of that particular isotope, of a particular isotope, we ask for the mass of a particular isotope, it's easy, right? We add the protons plus neutrons. And for example, with carbon, we're going to get 12. But for some molecules, for some atoms, it's, they've only got, 5 neutrons. So they end up with carbon 11 or carbon 13, right? So if we pick up a bunch of, like, a big handful of carbon, some of it's going to be carbon 12, some of it's going to be carbon 13, right? So what we need to know is what's the average relative atomic mass, so we need to kind of average them out. Imagine it this way. Imagine we were looking at a field full of ducks, a duck field, right? And we wanted to know the average weight of the ducks, right? But there are male ducks and there are female ducks, and the male ducks are maybe heavier than the female ducks. If we want the average weight of the ducks, we're going to need to find the average weight of the weight of the male duck, and then the weight of the female duck, and then we need to figure out, well, what percentage of them are male and what percentage of them are female, and then we can take that all into account, and then do our calculations. So let's have a look here. So we'll go back to chlorine rather than ducks. So 75% of chlorine atoms have a relative mass of 35, right? So we add up, protons plus neutrons, we end up with 35. 75% of them are 35. 25% are 37, right? So the calculation's really easy. It's 75% times 35 and 25% of 37, or 0.75 times 35, 0.25 times 37. Add them together and we get the relative atomic mass of 35.5, right? So if it was ducks and we said it was 50%, 49%, 3.5 kilos, and 51%, 3.7 kilos, we could then find out the percentage of the average weights of those ducks, couldn't we, right? So the relative atomic mass, takes into account each individual isotope, right? And it's kind of solved by the formula here. The abundance of isotope A, right, times the relative atomic mass of A. The abundance of isotope B times the mass of isotope B, right? And that's how you calculate the relative atomic mass of a particular element. And what you'll see is on a periodic table, these numbers down here, right, that's the relative atomic mass, right? So, for example, with chlorine, right, over here, 35.453, that's, taking into account the, that there are 75% of 35s and 25% of 37s, making the 35.5 or 35.45 if we want to be a bit more accurate, right? So that's how we calculate the number. That's how we get these numbers. So if you've ever wondered, why is it if the mass of an atom is just protons plus neutrons, how do we get 0.0122 when they're two whole numbers? How do you add 2 plus 2 or 4 plus 4 and get, or 4 plus 5 and get 9.0? It's impossible, right? The reason is because there are different isotopes of different abundances. You need to take that into account. Right, so now that you understand how you get this number, What we're now going to ask you is, how do you count the relative formula mass? So what about the mass of a molecule, right? Well, that's actually really easy. Once you know how to calculate the relative atomic mass, you're just adding them together. So for carbon, we'll see here it's 12, right, or 12.011. So for most calculations, we're happy with 12, right? For the oxygen, right, it's 15.999, which we might summarize to 16. So for the mass of both these, just 12 plus 16 is 28, right? So it's actually really simple. So for Na2O, you'd have a look at Na, you'd put two of them. So it's 23, 23 times 2 is 46, 46 plus 16, right? 23 times 2 plus 16 is 62, right? That's as easy as it is. That's as easy as it gets. That's all we're going to talk about today. Answer the question below, and I will see you in class.